Now we're going to take a look at some virtualization basics. So why do we virtualize? To start with, let's take a look at the traditional model. So we acquire a server, we install a server operating system onto it, and then we install an application onto that server. So in this case, we have Windows Server 2019, and we're running Active Directory on it. This is our domain controller. Then we acquire another server, we install Windows Server 2019 on it again, and then we have Exchange 2019 running on that server. That Active Directory server has one quad-core CPU, 16 gig of RAM, and 500 gig hard drives in a mirrored pair. That's actually a lot of resource. It's not going to use anywhere near that much, but that's just about the lowest spec server we could acquire at the time in current availability. The Exchange server does require a bit more. So it's got two quad-core CPUs, 16 gig of RAM, and again a pair of 500 gig hard drives. So there's a bit of wasted resource there on the domain controller. The Exchange server may need all of that, it may not. And then we bring along another server. So in this case, this is our backup server. And you'll notice that on that server, we're running Windows Server 2016 because it's not compatible with Windows Server 2019. And again, it has one quad-core CPU, 16 gig of RAM, and a pair of 500 gig hard drives. And again, it's not using anywhere near all of that resource. And of course, if we lose that middle server, that Exchange server, well then that application becomes unavailable. We lose the operating system and the applications running on it. So if that server's just had a motherboard failure, we're having quite a stressful afternoon at this point trying to get our Exchange server back online. Now, one way we can solve some of those problems is through the multi-purpose server model. Let's take a closer look at that. So we have a physical server. It's got a little bit more resource than the ones that we used in previous examples, but it has an operating system on it and all of the apps on that same server. So with all the apps being on one server, we have less wasted resources. Instead of 3 big servers, we have one with a little bit more resource in it to account for all of those apps. Now, this might be the only option for a small business, but it's not recommended. This is because of compatibility and conflicts between the apps and services. The OS in this example, we had to downgrade it to Windows Server 2016 because that backup application isn't supported on Windows Server 2019. Of course, if we lose that server, we lose the lot. We lose the Exchange, we lose Active Directory, we lose the backup application on there, and any other apps we might put on there. We might have put a line of business app on there. So again, losing that server will lead to a very stressful afternoon. If the backup application crashes or causes the OS to hang, so maybe a memory leak causes it to consume all of the memory in the OS, then all of those apps become unavailable. So our backup application could actually cause an outage on our Exchange 2019 server, and again, give us a very stressful afternoon. And then we've got security concerns as well. The Exchange 2019 service that's running on there has the Outlook Web Access service on there. If that hasn't been correctly patched, you could well find that it is compromised and someone accesses this server through that Outlook Web Access interface. And at that point, all of the apps and services running on that server could well also be compromised. And for example, they may lock you out of your backup solution and encrypt all of your files. So at this point, you're in a ransomware attack and you're having to pay the ransom because you can't get to your backups. And this is why for compliance, many modern security standards like Payment Card Industry Data Security Standard or PCI DSS, the Cyber Essentials Standard in the UK, and many others demand or at least recommend one role per server. The other thing is, in the same way that backup application could cause the operating system to hang and cause an issue for all the other apps, any maintenance that we need to do on that backup tool puts the other apps in scope. Let's say we want to apply a service pack to that backup application, and that is going to require us to reboot the server. We don't want to do that during the day because Exchange is also on that server. So at that point, we're having to arrange out-of-hours downtime on that server and all of those applications just to update the backups. It would be a lot better if that backup was separated out, then we could update it and reboot the server and the users wouldn't even need to know. And then finally, we have the issue of role segregation. So the backup administrator will have access to the server where Exchange is. So for example, that administrator could apply an update, for example, a .NET Framework update, which causes issues for your Exchange environment. And that leads to what we call error too many fingers on the keyboard. And then, of course, we have the virtualization model. In this model, we have our physical server. Again, it's got 2 quad-core CPUs, 20 GB of RAM, and a 1 TB RAID 5. But this time, instead of installing an operating system onto it, we install a hypervisor. Now, for our purposes, this will be VMware ESX, but it could be Hyper-V or KVM or any number of other hypervisors that are available. And on that, we create a virtual machine or a VM. We give it 2 virtual processors and 2 GB of RAM. Then we install our operating system onto it, and then we install our applications. Then we create another virtual machine. We give it 4 cores, 8 GB of RAM, another operating system, and we install our Exchange application onto it. And then we have one more VM with 2 cores, 4 GB of RAM, Windows Server 2016, and our backup application. So there are no wasted resources. The VMs are assigned only the resources they need. You'll note that domain controller only has 2 processors and 2 GB of RAM. Windows Server 2019 will actually behave perfectly happily with that amount of resource. The Exchange application needs a little bit more. The backup app, we've given it a little bit more again, because although it's not going to use a huge amount during the day, overnight when it's attempting to verify backups, it may require a little bit more. We have segregation of all of the apps and roles into separate OS instances. So no longer can the backup application cause an operating system level issue which impacts the other applications. And the fact that we have different OS support isn't an issue. That backup app is running on a Windows Server 2016 operating system, but our other apps are running on Windows Server 2019. This is secure and meets the compliance requirement. Of course, there are other caveats. We need to make sure that what we are doing beyond that is secure. But those issues of having these apps running on the same physical server are no longer an issue. And as I say, app hangs and crashes are contained within that VM. But we are still vulnerable to hardware failure. And this is where the next benefit of virtualization comes in: high availability. Now, with high availability, we have 2 physical servers. 2 of our VMs are running on one of those servers, and the other VM is running on another server. In the event that that server on the left hand side were to fail, for example motherboard failure or power supply failure or something like that, what will happen is the high availability service, in this case in VMware HA, will restart those VMs automatically on the other host. Now there's an important distinction here. There is often an assumption that these move seamlessly onto the new host. They don't. They are booted fresh. All of the storage is there in the SAN or other shared storage, which we'll come to. So it starts the VMs afresh. It cannot resurrect them seamlessly, so there will be a few minutes of downtime. We also have mobility, so in the same way that we can have the VMs automatically restarted in the event of a hardware failure, we can also manually move them between hosts. Now that is seamless. The operating system does not restart, it is carried across in its current state. Usually you might see one ping lost. For the most part, users don't notice. I regularly do this with terminal servers where the users are actively using the platform and they don't notice. But all of this, as I mentioned, does rely on shared storage. Both servers need to be able to access the same storage, whether that be a SAN or a direct attached storage array. We'll come to that in more detail later.